Quiz of Unit 3 are solving quadratics. What did we do last unit? We graphed quadratics. So it says, we've looked at graphing quadratic functions and how graphs of quadratic functions can be used to model real-life situations. Give me a real-life situation that can be modeled with a quadratic. Throwing a ball, right? Projectile motion. Can anyone think of something else that was modeled using a quadratic during this whole Unit 2? Something else that might have a maximum value or a minimum value. Can you think of one other example maybe? We did a couple. Throwing a ball. Projectile motion, a rocket could also have a maximum height, right? And then it falls to the ground. There was one about a dolphin jumping out of the water where it would touch the water. They were launching water balloons. So there was also talk about profit, right? Where would be the maximum profit? What would be the cost of whatever it was? I think it was a hairdryer. What cost would produce the maximum profit? We're going to look at maximum area. So if you have so much fencing and you have to use that perimeter of fencing, did you know that maximizing the area, right? Anyone know this from geometry? Like if I use the same amount of fencing, so let's say I have a 1 by 9. How much fencing have I used? A total of 20, like 20 feet of fencing. You with me? 1, 9, 1, 9 adds up to 20. What's the area of that enclosure? Only 9, right? 9 square feet. All right, so what if I take it instead and I put my perimeter as 5, 5, 5, and 5, and I build a square enclosure? Have I still used the same amount of fencing? Can I enclose a lot bigger pasture for my whatever goat? What's the area of this enclosure? 25 square feet using the same amount of fencing. So if you've got a small animal, you would definitely want to maximize their, their kennel. So we're going to talk about using quadratics to maximize area. And they actually do that in real life because they want to use the materials in a smart way. So we will learn how to solve quadratic equations graphically and algebraically. So there's going to be, I think, how many? 1, 2, 3, 4, 5, 6 or 7 strategies that you'll have in your toolbox to solve a quadratic, because we're going to learn 4 types of factoring strategies: square roots, quadratic formula, and graphing. So 7 strategies in your toolbox. So as a mathematician, you need to know how to pick the best strategy to solve a given quadratic equation, right? We'll also see that quadratic functions can have no solution, 1 solution, or 2 solutions. So here's kind of the layout of this week. Let's just look. No quiz this week. So this week we've got learning how to factor a bunch of different ways. And we're going to do a group problem again on projectile motion. And then if you look on Monday, we're going to do practice review for a quiz on Tuesday. That goes on quarter 2. Because I don't want to give you a quiz that can't get overridden before the end of the unit. So we will have a quiz on Tuesday, but that's not going to go in until quarter 2. But these couple homework assignments, 3-1, 3-2, 3-3, that's going to go in on quarter 1. This is that following week right before grades close. So I'll put probably 3-4, 3-5, 3-6 on quarter 2. But this week's stuff, we're still a week out. So plan on 3-1, 3-2, 3-3 going on this week's or this quarter's, grades. So those will be kind of the last 3 things for this quarter going in, is what I see. And maybe this group problem. That gives you a week to kind of make stuff up. So you have 2 nights to do solve graphically homework 3-1. You can do it tonight because all it is you graph a quadratic and you tell me where the x-intercepts are. Okay? All right, so here's what I did for you. I labeled your resource pages with a page number now. So it'll say resource 3.1 up at the top so that I can say, okay, turn to resource 3.2, turn to resource 3.3. So hopefully that'll help us have it organized. I'm going to start on this Unit 3 resource page, and then we're going to talk about page 301, and then do a group problem about rectangles. Everyone see where we are? So resource 3.1, which is the kind of 10 pages at the front of your packet. What does solving a quadratic function mean? The big idea of this unit is to find solutions to a quadratic equation. So what is a solution? Solutions to quadratic equations are the x-intercepts on the graph. But we could also call them solutions, roots, the root of the problem, a zero. What's the zero? That's what your calculator calls it. Remember we found the zero of the graph? Or x-intercept. So to me, that's a really big idea, because if you don't know what the question is asking you, right? So what does solving a quadratic function mean? It means finding the x-intercept. So put a big star, right? Because if it says solve the equation, you're finding what x value makes the equation zero. So here's all those strategies I was saying. Actually, we're not going to do completing the square this year. So you can cross out completing the square. We're going to save that for just advanced. But if some of you are going to, you're definitely going on to pre-calculus, maybe I should show you completing the square just so you've seen it once before. But we could talk about that. But for Algebra 2 CP, we're going to use these strategies. So here's what it means today, solving a quadratic graphically. All it means is when you have a graph of a quadratic, here's my function. I already graphed it for you. The x-intercepts are what? -1 and +2. So if I was going to write it as an x-intercept, I would write it as -1, 0 and 2, 0. See right off the graph? How do I write that as a solution? So the way that you write it a little bit differently as a solution is you write x equals -1 or 2. I should have given you a little bit more room. So to write something as an x-intercept, use coordinates. To write something as a solution, you just say x equals -1 or 2. You see how this is set up a little bit differently? This is y equals, standard form quadratic. This says x squared minus x minus 2 equals 0, solve for x. So we're going to learn some other strategies, but for now, graphing is our go-to, because we already know how to graph. So could you go through, what would you say for the second one on this resource page? Only x-intercept. 5, 0. So this is an instance, that's an instance when we only had one x-intercept, right? Don't die on me here. Because I was writing letters of recommendation on my couch without being plugged in. So late yesterday. So that's what got done instead of grading your quiz. Sorry. I had a deadline. Okay, is this still going? All right. So here's an instance where I had 2 solutions, but here's an instance where I only had 1 solution to my problem, right? So my only solution is that x equals 5. X equals 5. Remember systems of equations? That was another time where we had sometimes many solutions, no solution, 1 solution. Kind of the same thing. There's multiple outcomes to this type of problem. Okay, this next one, concave down, but it still has 2 x-intercepts, right? One of them is at 1, 0. One of them is at 3, 0. How do I write that as a solution? X equals 1 or 3. So tonight on your homework, the directions say, solve the following quadratics by graphing. Be sure to state your solution, right? So if you get that your x-intercept is at like 1 and 5, right here you want to write x equals 1 or 5 to get in the habit of writing your solution. What happened on the last one on this? There are none, right? There's no x-intercepts, so therefore there are no solutions. Don't leave it blank. State like there is no solution, because if you leave it blank or you write 0, that means something, right? Leaving it blank means you didn't answer the question, and 0 actually could be a solution. All right, so that's the resource page on graphing. See how the next page is our factoring flow chart? This is going to be helpful when we start to learn all 4 types of factoring strategies, so I put that in there. But we'll skip ahead to page 301. 301, here you are. Solving quadratics, introduction, and solving graphically. There's our projectile. So it says, when will it hit the ground? based on the graph. So take a look at page 301. So 3 seconds. So we're going to learn strategies how to solve this algebraically. But for now, we had to look at a graph. Can someone tell me, because we keep going back to this, what does the y-intercept tell me in this situation? I'm launching a ball. It's the starting height of your ball. So I'm launching it from 3 meters above the ground. So my platform is up here, and then I'm launching the ball. So I feel like we keep coming back to y-intercepts, explain what it means, and sometimes people don't know what it means. What's the maximum height that I reach? Yeah, something like 12.5 meters. When did I reach my maximum height? At 1.5, or maybe a little bit past 1.5 seconds? Because I didn't launch it off the ground, right? So maybe at like 1.7 seconds, something like that. I could do negative b over 2a and find out. Okay. So let's complete a few more solving by graphing examples for practice. We should remember how to graph these. So graphing is not going away. These are both in vertex form. Some of you who have to retake the Unit 2 test, this will help you prepare for that retake. What does minus 4 do on this one? Down 4. And what does the minus 1 do on number 2? Right 1. Does that hopefully ring a bell? We don't want to forget those transformation rules. So on example 1, I'm just going to graph the parent function of the quadratic, right? So I start at negative 4. Do you remember the parent moves for a parabola? 1, 1, 2, 4, and 3, 9. So don't forget it. 1, 1. So from the vertex, I go over 1, up 1. 2, 4, over 2, up 4. Would look like right on the x-axis, right? And then 3. See, if I go over 3 and up 9, I would land at 5. So that is a parent function of a parabola that's just been shifted down 4. Did I solve the problem? So it says, let's complete a few more solve by graphing examples. What are the solutions to this quadratic? Right, so your final answer, x equals -2 or 2. Make sure to write your final answer. We've never had to do that before, unless some of you completed that practice from Friday. So you graph it, you find what the x-intercepts are, and you write what the x-intercepts are for your final answer. Okay. So this time I'm going right 1, but what does the 1/2 do that's in front? It makes it half as steep, right? So when you have the points, remember how to do this? 1, 1, 2, 4, 3, 9. You cut this value in half. In this case, did I already solve the problem? So all I really have to do is over 1 and up 1/2, just to show that the parabola kind of goes like this. I already found the x-intercept. So I would just graph one set of points to show that you know how to graph it, and then state the solution, x equals what? 1. There was only one x-intercept to this problem. All right. Let's see. I want you to try number 3 and 5 on your own, and then we'll do 4 and 6 together. Why am I giving you 3 and 5? Those are in vertex form already. Why am I saving 4 and 6? Standard form. We can do those together in a minute. You try 3 and 4 and see if you can find the x-intercepts. So I'll pause it for a minute. Above the x-axis, right? So you should have gone left 4 and up 1. And if I just do one set of points to show that the parabola goes up, there's no x-intercepts, right? So I can just write no solution. Make sure you wrote no solution. Don't write that your answer is 0 or something. Okay, what about the next problem, number 5? Where did that one start? -2 goes to the right, right, because it's opposite. -4 goes down 4. So to find my vertex, I go right 2 and down 4. So there's my vertex. Then I'm going to do the parent moves, 1, 1, 2, 4, 3, 9, to get my, until I find the x-axis. So if I do 1, 1, that does not get me to the x-axis. But if I do 2, 4, I hit the x-axis, right? It won't always hit the x-axis so nicely. These problems are set up so that you land on an integer. If I didn't land on an integer, would you know what the x-intercept was? You would just know it's like 4 point something. So we would need a calculator, but these are set up for you. So x is equal to 0 or 4 was your final answer for that one, right? Okay, I saved the hardest two for last. They're only hard because you've got to do the standard form problem. So how about I do number 4 with you and then you try number 6? So let's review how to do negative b over 2a. So this is set up as a, b, and c. So b is 2. So if I plug it into the equation, I would have negative 2. And then 2 times a, my a value is negative 1. So 2 times negative 1 would also be negative 2, wouldn't it? So my x value is positive 1 because negative 2 divided by negative 2 is itself, so 1. I have to plug 1 into this quadratic. When I have a negative sign in front of the x squared, I do the 1 squared first, and then I still have a negative in front of it. So this is negative 1 plus 2, because 2 times 1, plus 8. What would I get as my y value? 9. Okay, so I'm going to go 1 comma 9, and then can you see how this is going to hit the x-axis very nicely? Because 9, right, 3 comma 9. All right, so graph it. You're going to go downwards because it's a negative sign, but you're going to use 1, 1, 2, 4, 3, 9, and see where it hits the x-axis. So go over from the vertex, 1, 1, and then over from the vertex, 2, 4, 3, 9, and bam, you should hit the x-axis and state your two solutions. See, I'm going to put mine up here for the sake of the video. 1, 1, over 2, down 1, 2, 3, 4 on each side, and then over 3, I should hit the x-axis right here. Over 3, I should hit the x-axis right here. Then I should connect my parabola so it's a graph. So let's see, did you get negative 2 or positive 4? Negative 2 or 4? On your homework tonight, if you've got like a graphing calculator in one of the rooms, if you're doing it like in Flex or on your phone, you could check that you have the right x-intercepts, right? So if you're stuck on how to graph it, use a calculator to just practice. All right, you try number 6. You're going to try to do negative b over 2a yourself this time. Find the vertex. Don't forget that there's a stretch here. So when you graph your quadratic, right, you'll have to go and double. You'll have to double these, right? So 1, 2, 2, 8. I think it lands on an x, on the x-axis. So if I get negative 1, 1, and I'm going up over 1, up 2, I never touch the x-axis. So this would have no solution. All right, 7 is just a quick review of, remember the box method for FOIL, just to keep that skill fresh. See if you can multiply out 7, and then see if you can answer number 8 on your own, just to wrap up this practice. And then we're going to kind of break into groups to do a completely different activity related to rectangles and team building. So try 7 and 8 on your own. Make sure when you do 7b, before you start, you write out negative 6x plus 2 times negative 6x plus 2. You are not allowed to just distribute this squared symbol. You have to use the box method. Does everyone remember the box method? I think you were pretty good at the box method, right? Box method, you just write out your 2 by 2 box like this, and you've got 4x minus 4 on one side, negative x plus 9 across the other side, and you're going to multiply to get the inside of the box. And then you're going to write your final answer. Anyone need help? Remember? So this is awesome. If you're going to retake that Unit 2 test, this was a skill that I think a lot of you already had. So we just reviewed a lot of retake. The only thing we didn't review today was domain range and some of those other parent functions like linear, absolute values, square root. But you guys still have your flashcards, right? So if you have the flashcards, you could those two. I'm going to put up my 7a and make sure we have the right idea. This would be negative 4x squared. This would be 36x, positive 4x, and negative 36. So it'd be y equals negative 4x squared plus 40x, right? Minus 36. Is that standard form right there? So there's my number 7a. Oh, hold on. Double check for yourself that you did 9 times negative 4 and that you didn't add 9 plus negative 4. A lot of times people make that mistake. So that feels familiar. So try to finish up B and then number 8. See if you can do that. So any questions on that? So I feel like day 1 of this unit really is a review of, hey, we're going to graph them and find their x-intercepts, right? And the whole projectile motion thing was